Hello everyone, so we've made it to chapter review finally. All right, I have not had a second to type this up for myself, but by this time it's uploaded, I will have the link to this packet in the description for you. So again, go ahead, print it out, try to do as much as you can, and then check it as I work it through in this video. All right, let's get started. So the first thing you're going to need to know is definition of fundamental theorem of algebra. Basically, it says that a polynomial of degree n, so n being any number, will have n number of roots. So as an example here, how many roots will this function have? So we count the powers, okay? So this is a power of 1. This is also a power of 1 on there, power of 3, and a power of 2 on this one. So 1, 2, 3, 4, 5, 6, 7. So we'll have 7 roots. Okay. And the next one you'll need to know is the factor theorem. And it says a polynomial has a factor x minus k if and only if f of k equals 0. So like your factor is x minus 2, so x equals 2, but it can only be a factor if it's a root. So 2, 0 is the point on that function. All right, find the polynomial if its zeros are -2 and 3 minus 4i. So again, set up your roots first. Remember, it's plus and minus 4i, right? All right, move it over. Okay, move that over so we can isolate the I. Okay. Square both sides to get rid of so 4 squared 16, I squared, which we know to be -1. And also in this step, I'm going to go ahead and FOIL this. 16 times -1, -16, add it over. Okay, now now we have our factors. Okay, so x plus 2, x squared minus 6x plus 25. Okay, and I'm going to show you how I do this just to make things a little bit easier. I go ahead and FOIL out or distribute out the x first. So x cubed minus 6x squared plus 25x. Now when I distribute the 2 through, I line it up so that when I can just add straight down. So 2x squared minus 12x plus 50. Okay, add straight down. Okay, and there's our function. Okay, next is find the end behavior of this function without using a calculator. Okay, so remember the first thing we're going to look at is the lead coefficient. So it's negative times a positive times a positive, so it'll be a negative. So it's negative, so the right side ends down. And then we look to the lead power. Okay, 1, 2, 3, 4, 5, 6. It's 6. It's even, which means left side follows the right side, so it's going to end down as well. So how we write that as f of, as x goes to positive infinity, f of x goes to negative infinity. And as x goes to positive infinity, or negative infinity, f of x goes to negative infinity. Okay, now find the domain and range of this. So range, we're looking for horizontal asymptote. Domain, we're looking for vertical asymptote. So first we're going to graph. Okay, so okay, so we definitely have some vertical asymptotes, and we can see there's a horizontal one too. So how do we find our horizontal asymptote? We must look at the powers, right? So we're comparing the powers of the numerator versus the denominator. Okay, so horizontal asymptote, since they're equal, we're going to divide the lead coefficients, which is 1. So we have 1 at y equals 1. Okay, number 2, our vertical asymptotes are the zeros of the denominator. So what we're going to do, since it's x cubed, what we're going to do is actually just graph the denominator. Because we're only looking for the zeros of the function in the denominator. So we'll go here, okay, trace, because it looks like it's -2, yep, -1, yep, and 1, 2, 3. All right, so we have vertical asymptotes at x equals -2, -1, and 3. Okay, so our domain is all real numbers except x cannot equal -2, -1, or 3. And range is all real numbers except y cannot equal 1. Okay, for the next one, for the function, find the following. Okay, well first we need to see if we can factor. All right, so let's pull a 2 out of that numerator. Okay, and now we can do difference of cubes. So first it follows the sign, x squared opposite the sign, and always positive. So SOAP, same, opposite, always positive. Okay, so that's our numerator. Let's see, do we have any factors of -4 that add to +3? Yes, 4 and 1, and that would be negative on the 1. So x plus 4, x minus 1. Does anything cancel? Nope, so we don't have any holes. Okay, so now let's look for the y-intercept. So all we do for the y-intercept is put zeros in for our x's and solve. So if we put zeros here, we get -16 divided by -4, 0, 4. Our x-intercept is we're going to set the numerator equal to 0 and solve for the x. Okay, so the first factor we have is 2. So we have 2, 0. Hey y'all, so sorry the lighting is a little different. While I was editing this morning, I just did not communicate this clearly, so I just want to come back and reiterate this. So after you do difference of cubes or even sum of cubes, this is going to be your only factor. This part will not have a root, okay? So we can check that by graphing it. And you'll see it never crosses the x-axis, okay? So we just know that whenever we do sum or difference of cubes, this will be our only root, and this will not have any real roots. Obviously, it will have imaginary roots, but it will not have any real roots. Okay, thanks. All right, so now next is our vertical asymptotes, which are the zeros of the denominator. So x equals -4. And x equals +1. Okay, now for our horizontal asymptote, we look to the powers. If the power of the numerator is greater than the denominator, there is none, but you have to check for a slant or an oblique asymptote. So over here, let's divide it out. Okay, so if you notice, we have x cubed, but we don't have a squared or x to the first. So we're just going to fill that in with zeros. Okay, what do we multiply x by to get 2x cubed? So that'd be 2x. So we get 2x cubed, pull it under, change the sign. 6x squared, pull it under, change the sign. Negative 8x, pull it under, change the sign. Okay, so we get negative 6x squared plus 8x, pull down that negative 16. And now what do we multiply x squared get to get negative 6? X squared will be negative 6. Okay, as long as this cancels out, we're good. And it really doesn't matter past that, okay? Because we have our line. So our oblique asymptote is y equals 2x minus 6. That canceled. All right, next, find the zero of this function. So in order to find the zero, we're going to set the equation equal to 0. Okay, add the 16 over. Okay, now since the variable is in the power, we need to make this a log. So the base of the exponential becomes the base of the log. Okay, so log base 2 of 16 . So 4 equals 3x minus 5. Add the 5 over, divide by 3. So x equals 3. So our 0 is 3, 0. How long will it take something to double if the growth equation is a of t equals 80 e to the 0.42t? Okay, so if we want it to double, we first need to know what we started with, which is going to be this 80 here, right? Because that's the principal, that's your starting amount. Now, if they didn't give you this, you would just drop this and this and just go straight into 2 equals 0.42t, okay? And you'll see why here in a second. So if we start with 80, we know our double amount is going to be 160. Okay, divide both sides by 80, we get 2 equals e to the 0.42t. Again, exactly where we would have been, okay? So now, since the variable is in the power again, we need to convert to a log. Now, log base e is ln 2 equals 0.42t, and then divide both sides by the 0.42. Okay. 1.65. So just over a year and a half. Okay, now what about this one? So first, we're going to have to use our properties of logs in order to combine into one log over here, because that way we can have matching logs on both sides, and then we can drop them. Okay, so since this is addition, it'll go into multiplication. So log base 12, and let's go ahead and FOIL that out. Okay, now that we have matching logs, they go away. So x squared plus 4x plus 3 equals 17 minus x. So we'll subtract the 17 and add the x. Okay, now do we have factors of negative 14 that add to 5? So that'd be 7 and 2, and it would make the 2 negative. So we have x plus 7, x minus 2. So our zeros are -7 and 2. Now we have to go back in and double check, because remember, we cannot have a negative number in this part of a log. So if you plug in the -7, that gives us -4, gives us -6. So -7 is not one of our options. If we plug in 2, we'll get 5, 3, and +15. So x equals 2 is our only answer. All right, number 10. Items are being sold. The first item is $10. Then items 2 through 10 are $9 each, and items 11 and higher are then $8 each. If a customer is charged $115, how many items were purchased? Okay, so the first thing we're going to do is, well, we have the first item, which is $10. And then we have items 2 through 10, so that is 9 items. Okay, so let's see how much we're at now. So 9 times 9, 81, plus 10, so that's 91, which is still less than what we have here. Okay, so then 81 plus, and they're $8 each. Okay, so we get 91 plus 8x, oh, sorry, equals the total, 115. Okay. Subtract the 91 over. So x equals 3. So now how many total items did he purchase? Well, we had 3 here, we had 9 here, and 1 here, so 13. Okay, graph the piecewise function. So again, first thing, okay, we're going to put dividers, not vertical asymptotes, but just a divider to remind us where these equations or these subfunctions change. Okay, so from this divider over, it's this first function. Between the dividers, it's this middle function. And from this divider to the right, it's the bottom function. Okay, so now let's plug in -1 here. So we get -4.4. Okay, and then let's see what that graph looks like. No. Okay, and all we need is from -1 over. So from there over, that's all that really applies to us. Okay, so we're going to do -1, 1, 2, 3, 4.4, and it's going to be closed. And then it has a little bit of a curve on there. All right, so now our second one, let's plug in -1 here. So -1 plus 1, 0. Anything raised to the 0th is 1. 1 minus 3 is -2. So we go -1, -2, open circle, because it doesn't exist at -1. Okay, now okay, and we're going from between -1 and +2. So let's see if we get 2, 5. Does it exist there? Yes, so it's going to be a closed circle. And we'll try to make this a little accurate. There we go. Okay. I guess I could have gotten the Y-intercept correct, but always get the Y-intercept. So -1. So it really should have crossed. Oh. So it should have crossed here. Now let's find what that x-intercept is. So like 0.6. Oh, I was way off. Okay. There. So something like that. Okay, now this one. Let's just go ahead and straight graph this one. Okay, so trace, and it starts at 2. So let's see what our value is. Okay, that is our vertical asymptote. So we technically do have one here for this function. So, all right, so now let's see what our next value could be. So we have 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. And we know our horizontal asymptote here is going to be 2. So it's not going to come across that. Something like that. Okay. Next, find the polynomial that has zeros at -3, 4, -2i, and has a solution at -2, -24. All right, the first thing we do is set up our roots to become factors. Okay, move those over. And then we're going to have to square both sides first. Okay. Again, that's -1. So x squared equals -4. Move that over. Okay, so now we have our factors, x plus 3, x minus 4, and x squared plus 4. Okay, FOIL it out. Okay, and now distribute that. So we get x to the 4th plus 4x squared. Distribute that. Distribute the -12. Okay, so the 4th. Okay, add straight down. Okay, well, actually, no. We don't know that yet. So now we put an a in front, and that equals f of x. Now we plug in our point, okay? So our x's are -2 to the 4th minus -2 cubed minus 8, -2 squared minus 4, negative 2 minus 48 equals negative 24. Okay. So we get 16. So that'll be negative 8 times a negative is a positive 8. Positive 4 times negative 8, negative 32. Positive 8 minus 48 equals negative 24. So now 16 plus 8 minus 32 plus 8 minus 48 equals negative 48. Okay, divide both sides by the negative 48, and we get 1/2. So our function will be 1/2 x to the 4th minus x cubed minus 8x squared minus 4x minus 48 f of x equals that. Now, if they want the whole thing, oh, sorry. If they want the whole thing, you would just distribute this through. Okay, sorry about that. I didn't realize it had gotten so dark. I've got a ring light on, so it may flash occasionally just in case you need to know that. Okay, but we've only got 2 more. Let's get started. So for the piecewise function below, determine the value of k to make the function continuous. And remember, in order to be continuous, the endpoints need to meet. Okay, so the first thing we're going to do is plug in 2 for this one. So if x is 2, our y is, so 2 cubed minus 4 times 4 plus 3. So 3. Okay, so we want these equations to meet at 3. So what we're going to do is set this equation equal to this and plug in the 2 here. So 3 equals the cube root 2 plus 6 plus k. Okay, 2 plus 6 is 8. Cube root of 8 is 2. Subtract the 2. So k equals 1. All right, now find the domain and range of the following graphs. Okay, so remember domain, you go left to right. Okay, we don't see any breaks in the domain, so our domain is all real numbers. Our range from bottom to top, okay, we have a break between 0 and 1, and it exists at both of those points. So our range is negative infinity to 0, union, bracket, 1 to positive infinity. All right, next one. Okay, going across our domain, we have a vertical asymptote at negative 4. And then no break, and it goes to positive infinity. Okay, our range ends in an arrow, so negative infinity ends in an arrow, so positive infinity. Last one. Okay, again, vertical asymptote here. So that's negative 2. And we do have a break from 0. And does it exist at 0? No. Okay, so it goes to 0, parenthesis, union, bracket, 1 to positive infinity. And our range, okay, well, it doesn't go down, it remains constant at negative 2. So it's just negative 2, bracket, union, it doesn't exist here, but so 1 to positive infinity. All right, let me know if you guys have any questions over things I didn't get a chance to cover, or if something comes along and it's a harder question than we went over, just let me know in the comments. Thanks, guys.